इस लेक्चर में आज हम डिस्कस करेंगे ल्यूविले थ्योरम। ल्यूविले थ्योरम। The statements of Lieuville theorem. If fz is analytic in the entire z plane and modulus of fz is less than equal to m, so then fz is constant. Function is constant. So this is the statement of Lieuville theorem. Now we shall prove the theorem. So for proving the theorem, so we consider a circle. This is the origin. Now we have u and v. We write on z plane. This is the curve c, and we assume that the radius r, and we shall consider 2 points z1 and z2 which lie inside the circle c, and whose center is origin. So let z1 and z2 be 2 points in the circle mod of z minus 0 is equal to r, where r tends to infinity. Okay, radius tends to infinity. So now by using the Cauchy integral formula, by using Cauchy integral formula, first we write down for f of z1. F of z1 can we write 1 upon 2 pi iota integration along a curve c fz into dz upon z minus z1. For second point z2 which lie inside the circle c, so we write down as fz into dz upon z minus z2. Now we write down fz1 minus fz2 is equal to 1 upon 2 pi iota along a circle c integration. So we write down this as 1 upon z minus z1 minus 1 upon z minus z2 or into fz dz. fz dz. So we write down this as 1 upon 2 pi I integration along a curve c. So we can take the LCM as z minus z1, z minus z2. So we write down this as z minus z2 minus z or minus minus plus z1 or into fz or dz. So here z to z cancelled. So this we can write down z1 minus z2. So we write down this as 1 upon 2 pi iota integration along a curve c z1 minus z2 upon z minus z1 z minus z2 or into fz dz into fz dz. So this is equal to f of z1 minus f of z2. Now taking modulus both sides. So when we take modulus both sides, so we can write down this as modulus of f of z1 minus f of z2 is equal to modulus of 1 upon 2 pi I integration z1 minus z2 upon z minus z1 z minus z2 into fz dz. So this can be written as less than equal to 1 upon modulus of 2 pi I integration along a curve C, so mod of z1 minus z2 upon mod of we write down the z minus z1 and second we can write a mod of z minus direct लिख दिया मैंने यहाँ पे mod of z2 और here mod of fz and mod of dz modulus of dz. So this can be written as less than 1 upon less than equal to 1 upon 2 pi iota when we take the modulus of this so we 1 so modulus of iota so this is 1 upon 2 pi or given that modulus of fz is less than m so this can be written as m we write down as m and we take as a modulus of z1 minus z2 upon value of z mod of z सर्कल लिया है हमने क्या mod of z minus 0 is equal to r radius r so mod of z equal to r so we can write down here as r minus mod of z1 for first one or second similarly r minus mod of z2 r now so we have an integration along the curve c into dz or dz of c be the circle. Okay, so we can write down this as less than equal to m upon 2 pi. So m upon 2 pi z1 minus z2 upon r minus mod of z1 or r minus mod of z2 or integration इक्वल टू 2 पाई r जो थीटा की लिमिट्स हो जाएंगी थीटा लिमिट्स विल बी थीटा इक्वल टू 0 टू 2 पाई और z माइनस 0 इज इक्वल टू r है तो z इक्वल टू r e रेज टू द पावर आयोटा थीटा और dz इज इक्वल टू I r e रेज टू द पावर आयोटा थीटा और d theta. So when we do the integration, so we get the value is 2 pi r. So we get 2 pi r. So we see that so when r tends to infinity अगर radius tends to infinity increase होगी तो then the value of the function tends to 0 so this gives us 0 when r tends to infinity the function tends to 0 the function tends to 0 so we see that this is the modulus of f of z1 minus f of z2 is equal to 0 so here we can say that f of z1 is equal to f of z2 तो फंक्शन दैट मीन तो डिफरेंट पॉइंट लिए से दोनों पॉइंट सेम आ गए एफ ऑफ जेड वन इक्वल टू एफ ऑफ जेड टू तो वी कैन से दैट बट जेड वन एंड जेड टू आर एनी आर्बिट्रेरी पॉइंट the arbitrary points. So then the value of the function remains constant. अब दो points पे value same आ रही that the function constant होगा. The function constant, so we can say that fz is constant function. Function fz is constant. So this is the proof of the Lieuville theorem.